Hello, I'm going to demonstrate a unipolar Hall effect sensor test because you have bipolar latching as well, but this happens to be a unipolar. So here we have a power supply and I've set it to around 4 volts. So what I'm doing now is I've got my meter here. The positive lead is going to the positive side of the power supply, and also the positive side of the power supply then is going to the positive VS. That's the source on the Hall sensors, which are all connected together. So the positive feeds, this is upside down, so usually when it's the other way around is leg 1 of the Hall sensor, but because it's upside down it falls on the last one here. So every last leg is positive, and then the middle leg is the negative, which goes to the power supply, and the signal is the first one here, which would be the last one if it was the other way around when you see it, because it's upside down. Yeah, so here I have a magnet, and if this was latching it would stay on because it's bipolar, so you have to change polarity to latch it off and on. But this is unipolar, so what will happen is on a unipolar is when I take the magnet close to it, it will signal out, and I'll show you that. And when I take the magnet away, it goes, the signal will die. But on a unipolar, it will latch, it will stay on until you show the other side of the magnet. So this is not going to do that because this is unipolar. And also the negative side of the meter is going, because this is a hub motor, this is the phase wires, and inside here is the Hall sensors. So you have, on these you have positive, negative, and 3 Hall sensors with 3 different color signals. Now I've got the meter onto one of the signals, which is the middle one here, and I've just changed it, so I'm going to test it. So if I turn on my power supply, which it's about 3.3 volts will do. So basically the meter is on 0. So I take the magnet and I go close. I turn the magnet and I go close to oops, what's going on? Yeah, so take the magnet, we are on DC, take the magnet, positive, negative. Okay, sorry, I'm connected to the last one, the first one, which is the yellow. So if I turn the power supply off for a second, don't want to show anything, and I move this onto the middle one, yeah, that'll be the middle sensor because that was the first one. So look at the meter, and I go turn the power supply on. I got the magnet, turn the magnet, turn the magnet. I've got my hand here, so take that, goes to 0. So go to the middle one. Yeah, that was the middle one. So this one is not connected at the moment. That one's not connected. So if I want to switch the last one on now, then I go down here, turn the power supply off first, go down here and move that to the last signal. So now I see the meter. Turn the power supply back on. 3.3. So 3.3 volts, and you will see 3.3 volts here. So go to last one now. 3.3. So that's working. That one I got to change signal, and the first one, let's go back to the first one now. Go back to the first one. And I didn't turn the power supply off, and let's hope I didn't show anything. So there's the first one now. So if I move it away, it goes to 0. So unipolar. So if I turn the magnet, it doesn't do nothing. So it's, I think, on the north pole I've got to have it on. So what would happen in a bipolar is when you put the magnet like that, the signal comes, and when you take the magnet, the signal stays until you turn the magnet and go like that and you switch it off. But these are unipolar, not bipolar latching. So this is a test for checking out your hub motor's Hall sensors.